Hey gang, so common naming wasn't that bad, right? So like I kind of hinted at in the last episode, sometimes the structures get a little bigger or they're kind of arranged differently and we can't use our common names that we learned in the last video. So we have to kind of use a strategy called IUPAC or systematic naming. IUPAC just stands for International Union of Pure and Applied Chemistry. They're the big whizzes that make up all the rules and stuff that we follow when we usually do some stuff in Ochem. But I promise you, while this is maybe a smidge boring and some teachers hate naming because we have software to do it now, it is kind of important to know. And the best part is it's not that hard. It's just you kind of have a process, you follow the process, and that's really it. So the way this video is going to kind of work is I'm going to pause it every once in a while. I'm going to draw some stuff on the board, and then we're going to go through the naming together, but I don't want you guys to see me drawing the structure. I want to make sure I can get this efficiently done and the video flows well. Okay, so this is the first of 3 problems we're going to do in this video, and I've kind of designed them to kind of cover the basis. I don't want to keep you guys in this video for a long time showing you something that really, if you just practice it, once you have some good fundamentals, you'll be good to go in. So we're going to do 3 problems. Usually when the video stops and another structure comes up, I would just pause it, draw this down if you're trying to work along, or if you're not, just keep watching. Okay, so here's the general process. The very first thing when you get any type of structure is to first do not freak out, because while it looks possibly scary at first, I promise you it's not. The second thing, if you don't have to not freak out, is you want to always find the longest parent chain, as we call it. Parent chain just means find the longest, streak of continuous carbons, and that's going to be the one you want to go with. So I know sometimes you might look at a structure, and this was a big problem I had, was you look at a structure and you just go, oh, it's so easy to go left to right. But just to be safe, and it takes a little time, count every way possible, right? So let's go. If we go left to right, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's a possible path. If you look, going this way and this way is the same, right? Because we have 1 carbon and a branch, 1 carbon and a branch. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 2 ways are the same, doesn't matter. Let's go here and this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we don't have to worry about that path because 10 is longer. The left to right way is longer. Let's try this way. That looks pretty long. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. So while it didn't matter in this case, it's still good to check. Alright, so once you found the longest chain, the next thing you do, well, let's number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. So now let's list our branches, okay? Use a different color for this. So on branch number 2, we have a methyl group, right? We have a branch and a CH3. If you look also ahead on carbon 5, we also have a methyl group, right? So here's kind of how we list, not only just list a group, but how we list a duplicate of a group. So let's go over here. So you write the number that it starts on. If there's more than 1, you do 2, 5, and then a dash. Every time you encounter a number and you go to write a word, you always separate it by a dash. If you're trying to write more than 1 number, you separate them by commas. 2, 5, and we have 2 methyl groups, so this would be written as dimethyl. If you have 3 methyl groups, that would be tri. If you had 4, it would be tetra. Okay, but just dimethyl. Now let's look at number 7. Skipping 4 for now, but let's look at 7. Okay? 7, we see 2 carbons off of it, right? That's an ethyl group. Ethyl. And you notice I'm using those YL endings. This is almost kind of similar to common naming, right? It's not part of the parent. We're looking at what it's attached to, so we're going to go with ethyl, propyl, stuff like that. Now let's look at number 4. 4 dash. If I were to cover this up, do you guys see how there's 3 carbons? And you also see how we're attached to the middle carbon? In our last video, we would have totally named that as an isopropyl, and you can do that exactly right here. That's why common names kind of come in handy sometimes. So I would write 4 isopropyl. And if you're thinking to yourself, I wonder if T-butyl, sec-butyl, all that stuff comes in handy also, You're absolutely right. Okay, and then on number 3, we have a bromine. And instead of writing 3-bromide or 3-fluoride, instead of the IDE ending, you give halogens kind of like O ending. So this is bromo, or fluorine would be fluoro, or chlorine would be chloro. But here we're dealing with a 3-bromo. Okay, awesome. Now that we've listed our branches, the next thing we have to do, and I hinted at this in the last video, is alphabetize. Okay? So let's go through the list and let's see which letters count for alphabetizing. So I'm going to go bottom up actually. So here, B. Bromo is absolutely the letter that counts. 4, iso. Iso counts. I. 7, there's an E. And the reason why I was saying that counts is because if we go up to here, we see dimethyl. Those prefixes like di, tri, tetra, those letters do not count. You have to go past the prefix, the numerical prefix, and look for the letter after that. So methyl is the letter that counts here. Okay, so let's I'll assign little number rankings to see how I'm going to write them. Bromo is definitely the first one we're going to write. Ethyl looks like it's going to be the second one, using the alphabet here. Isopropyl looks like the third one, and then he will be our fourth group. And at the end of these groups, our parent chain is 10 carbons long, so that's a decane, right? That is a decane. Okay, so here's how we write them. Ready? 3-bromo. Okay, now I'm going to go on to the next number, so I put a dash. 3-bromo, 7-ethyl. Then I'm going to go on to 4-isopropyl. Then I'm going to go on to 2,5-dimethyl. And then the parent chain, and if you're writing multiple words in succession, you just run them all together. So it would be 2,5-dimethyl, no dashes or ever, you just put decane. Okay, so I hope that first example went well. We're going to kind of kick it up a little bit of a notch in the next one. So let's do another example, pretty much on the same difficulty level as the one we just did, but with a little bit of a twist, kind of. Okay, so here's the structure we're dealing with, right? So our first step is to find the longest parent chain in the structure, okay? So let's count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 across. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's a no-brainer that we need to go along this path, right? So one thing I didn't mention in the video before, and I really want to make it apparent now, is, so do we number from left to right, or do we number from right to left? And here's the strategy you have to go about it. You kind of have to look at both options, and then you look to see, okay, am I assigning all of my branches the lowest numbers possible? And here's what I mean. So if we go from left to right, I would be numbering 1, 2, 3, 4 is where we hit our first branch, 5, 6. 6 is where we hit the second branch from going from left to right. Let me erase this real quick. Now let's look at the alternative, because we want to assign our branches the lowest numbers possible. Okay, so 1, 2, 3, 4, 5. Okay, so when we went from left to right, we had a branch at 4 and a branch at 6. However, over here we have a branch at 4 and a branch at 5. The fact that this branch comes first at 5 and this one comes at 6, we are going to number from right to left. So as soon as you see that first kind of breaking point where one way assigns a branch a lower number than the other, you're going to go that way. 6, 7, 8, 9, 10, 11, 12. Okay, awesome. So now that we've found, the parent chain and we've numbered it the correct way, let's, name our branches. So, okay, I see I have a methyl group at 4, methyl group at 5, methyl group at 9. So, I'm going to write 4, 5, 9, separating the numbers by commas, right? And I have 3 methyl groups, so I'm going to use a trimethyl. All right, cool. So I've handled all the methyl groups. At 6, we have an iodine, but we're not going to say iodide or iodine, right? We're going to say iodo. Iodo. Okay? Now, hopefully you're looking at 7 and it looks a little familiar and your common naming light bulb is going off in your head because, and I'll cover it up real quick, if I were to cover this up, you see we have 1, 2, 3, 4 carbons, but it's not kind of in the straight chain butane conformation, right? Because we have 4 carbons, that's a butane derivative. It looks like we're attached, if I were to cover this up, to a tertiary carbon. So this is a T-butyl group, or a tert-butyl group, whatever you want to say. Awesome. Again, common naming coming in clutch for us. Okay, awesome. So we've named all of our branches. Our parent chain is 12 long, so we know that that is a dodecane. Make sure you know those names for the lengths of alkane chains. They can't name systematically without them. Okay, so let's now alphabetize these branches. All right, so we know that in trimethyl, the tri does not count because that's a prefix that does not count. So I'm going to underline the methyl, the M in methyl. In 6, nothing's really tricky going on. The I is the first thing we're going to alphabetize with. Now 7's a little weird. Anything like sec or tert or T, those do not count, much like the di, tri, tetra. So you kind of skip past that and go to the actual name of your branch. So the B here in butyl, that counts. So we have identified all the letters. The T-butyl is going to come first. The iodo is going to come second. And you bet that the trimethyl is going to come third. Followed by the dodecane, the name of the parent chain. All right, so let's string them together. So first, we have 7-T-butyl. Next, we have 6-iodo. Remember, dash is between, when you switch between a number and a word, or a word and a number, commas between your numbers. So then we have 4, 5, 9, dash trimethyl. And remember, when you go from your last branch name to the parent, you just run the name together, right? So it's trimethyl dodecane. Okay, so hopefully that wasn't too much. You can see that there's a process. It's just a matter of kind of nailing that process down. The last one I'm going to show you might be a little, at least for your introduction to naming, but I wouldn't freak out. There is plenty of practice, a worksheet wholly devoted to this systematic naming. So don't worry, you're going to have plenty of practice, and let's tackle this last one. Okay, so this is the last problem of the 3 we're going to do in this video, and I promise you, it may look a little scary. It's really not that bad at all. Okay, so remember our very first step. Let's find the longest parent chain that is in this molecule. There's a lot going on, so let's make sure we kind of count all the different ways and make sure we have the right one for a fact. All right, so let's go from here all the way down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 14 carbons. Sounds good. Let's count from here on up to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm not worried about that. Now let's count from here over to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Close, but no cigar. That's less than 14. Let's count from here up to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Again, close, but less than 14. That looks like all the really big chains, so I think it's safe to say we're going to go from here to here. Now the question is, are we going to go from left to right or right to left? And remember, we need to find the way where we're going to assign our branches to the lowest numbers. And right off the bat, I'm going to say this way to this way, because right off the bat, if we go 1, we have a branch at 2, and over here, there is no branch at 2. So that was pretty easy. Okay. So let's keep, I'm going to actually move this 2 over here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay, so next step, let's name our branches. Okie dokie, let's go with blue. So at 2, I see a methyl group. So let's kind of see if there's any other ones in the molecule. We got 1 at 2, we got 1 at 4, 1 at 5, and 1 at 8. So over here I'm going to write 2, 4, 5, 8. And the prefix for 4 is tetra. So 2, 4, 5, 8, tetramethyl. Awesome. Knocked out all the methyl groups. Alright, awesome. So at 7, I'm going to come back to 6. 6 is the reason why we were doing this problem. 7, right, it's not fluoride, it's not fluorine, it's fluoro. F-L-U-O-R-O. Always spelled fluorine wrong back in the day. Okay, so at 9, alright, we have this cyclostructure, okay? So let's count how many carbons are in this. 1, 2, 3, 4, 5, 6. Okay, so it's a cyclohexane, but remember, it's a branch. So we're going to have 9 cyclohexyl, right? Just something we're used to. Drop the A-N-E, add the Y-L. And then 11 hopefully looks a little familiar, right? Isopropyl, right? Whoops. 11 isopropyl. Okay, now let's get back to 6 because there's a reason why I kind of skipped it. There's no really, so you've been noticing that we're assigning common names to the branches, right? Things we can handle. However, 6 doesn't really look like, nothing comes to mind as to what we can call that. So we kind of need to use what's called naming in parentheses. So I'm going to kind of like draw some parentheses around this guy. And here's how we go about it. If you ever come across a situation where you're like, oh damn, I do not know how to name that off the bat with a name that is pretty common, you have to use this strategy. So I kind of draw parentheses around it, and then you kind of have to almost like find your own little mini chain off the branch. So you always give the carbon directly off the parent chain in parentheses number 1. And then from there, you kind of have to number to make the longest chain possible. So 2, 3, 4, right? Because if we went 1, 2, 3, or 1, 2, 3, that's not longer than 1, 2, 3, 4. Awesome. Okay. Then what's kind of cool is you just name it like normal. So this is at position 6. So we put 6 dash, and then we're going to put a parenthesis right there, right? And so you can see this is a 2,2-dimethyl, right? So 2,2-dimethyl. But we're still on a branch, right? So this isn't it's not 2,2-dimethyl butane, it's 2,2-dimethyl butyl. You just kind of run, once you've named your branches, you run the parent chain in parentheses right at the end with a YL ending. So 6, comma, parenthesis, 2,2-dimethyl butyl. Awesome. And that takes care of all of our branches. So now let's alphabetize. Alright, so like here, we know that tetra does not count. So the M in methyl, that's what we're underlining. 7, fluoro. 9 is one of those things, iso and cyclo count. So C, that counts. I counts. And parentheses are a little weird. So I've told you in the past that the prefixes do not count. However, when you're in parentheses, you always go with the very first letter, no matter what. So the D in dimethyl, that counts. Doesn't matter if it would be just a methyl, or a tri, or a tetra, go with the very first letter. Okay, and the parent is tetradecane. So let's give these guys some numbers for ordering purposes. So it looks like, I used my little cheat sheet here. So it looks like the very first one we're going to deal with is the cyclohexyl, right? He's number 1. Then we're going to go with the D in the parentheses, right? He's number 2. Then it looks like we're going to go with the fluoro, then the isopropyl, and last but not least, the methyl. Alright, I'm hopefully going to have enough room to write this name, but if not, I'm sorry. I'll try my best. Alright, so let's go with 9 cyclohexyl. And then we'll do 6-2,2-dimethyl-butyl. Right, close the parentheses, dash. Then we'll go with 7-fluoro. Then we'll do 11 isopropyl. And then last but not least, last branch, we're going to go with 2458. Tetramethyl. I'll try and squeeze in, out enough space. Then we go with the tetradecane, and remember, run it all together. Tetradecane. Alright, sorry that was a little messy. Hopefully you can see all of that. So you can see that naming isn't so bad, right? It's just a process. Find the parent chain. If you have a tie, for the parent chain, look for the parent chain that has the lowest amount of numbering going on. Then once you find that parent chain, look to see if you need to number it from left to right or right to left. Then give your branches the names. If you have to use parentheses, go for it. Then make sure you are correctly underlining the letter for alphabetizing as needed. You give them some relative rankings, and then you write the name all together. Alright, so make sure you practice this worksheet, hit it hard, and we'll see you in the next episode.